We've just exploited the system via multiple different examples of tampering with untrusted data. So let's now spend a bit of time talking about how to defend against this attack. And the first rule of protecting against the risk of untrusted data is this: don't trust anything. You need to expect that every piece of untrusted data is malicious. And that means applying some fundamental controls to all of these external inputs. So let's talk about what some of those are. So I'm going to cover 4 different ways of defending against tampering. And the first one is what I just touched on the previous slide. Always assume malicious intent. So for example, before when I showed how I could change the user ID from my own to Nico Rosberg's and vote on the vehicle on his behalf, you need to assume that that ID will be modified because it is untrusted data. So there has to be an independent verification process of what the identity is. And the right way to do that would be to look at the authentication token of the user. Now, I talk a lot more about how authentication tokens work in Ethical Hacking Session Hijacking. And that course explains how the token should be a cryptographically strong identifier, and we use that to identify the user, not just some integer which is passed through as untrusted data. The next thing is we always have to verify on the server. So think about the hidden form example. I changed the user ID to Nico's, and the server never made sure that the person sending that vote was actually the same person whose user ID was sent. It just relied entirely on the untrusted data. It trusted the client. It didn't independently say, is this actually the user trying to vote? So verification on the server is absolutely critical because you can't trust the other data that comes to the server. So verification on the server is critical because you can't trust the untrusted data that comes via the HTTP request. Another thing to be really conscious of is client persistence. It is enormously dangerous. So we saw that hidden field with the isAdmin flag. We know now that you can't trust that somebody else could modify it. And persisting anything via client constructs, not just hidden fields, but things like cookies as well, and we use the same attack with the cookie, is enormously risky. Now you can use approaches like a MAC, a message authentication code, to persist data on the client and then ensure that it hasn't been tampered with once it comes back to the server. But certainly, simply persisting a value like that isAdmin flag anywhere where it can be tampered with is enormously dangerous. And finally, whitelisting allowable behaviors. Now this is a pretty fundamental principle when it comes to dealing with untrusted data. In the example before with the mass assignment attack, we allowed the application to save the isAdmin flag even though it should never have been sent back to the change profile page. What that resource really needs to do is to say these are the attributes that we're happy to bind. You can still use these nice modern model binding constructs, but you have to be explicit about which attributes of the model you actually want to persist and bind from untrusted data. Now you'll also see this objective, the whitelisting of allowable behaviors, repeated at multiple other times throughout this course. You're going to see it when we look at cross-site scripting, and if you've gone and done my Ethical Hacking SQL Injection course, then you would have also seen it there. And this is really a very, very fundamental tenet of information security. Be crystal clear about what it is you are going to accept from the user and what it is allowed to do. If it doesn't meet that criteria, then reject the request. So there are 4 fundamental things to think about when it comes to the risk of tampering of untrusted data. Let's now move on and summarize the module.